Hey guys, welcome back to another video by Stoby. Today's video is going to be a bit of an informational video. Recently I've been studying geology, and so I thought I'd do a video on the geology of Minecraft, because there are a few things that are surprisingly accurate, and some of it's quite interesting. So the first thing we're going to start with is stone. Now, stone is the basic block in Minecraft, and surprisingly enough, stone is not a type of stone. So, we need to classify it. And the way we do that in geology is we look at the grain size, so the little bits that we can see in it, how big those are, and also the colour. Now, we would say that stone is light coloured, like this diorite here or this andesite, and that we can't see individual crystals in it. We can see a generic colour, but no crystals. Therefore, we would say that it's fine-grained and light-coloured, and that would make it silicic, which is rhyolite. So we would say that stone is rhyolitic. Now, granite is a real type of rock, and you can tell, and it's a very good texture. Well done, Mojang. Quite big crystals, and the colour comes from a something called a feldspar, and that makes it the orangey-reddy colour. Most granite isn't this colour, but it's quite nice. Most granite is actually this colour, the colour of diorite. Now, diorite is quite similar to granite here, and it's the same crystal size, so coarse, as you can see, big crystal here, they're both coarse. And because there's more grey in this here, whereas this has got lots of light colours, ignoring the red, we would say that this is intermediate, so this is a little bit further along the scale, and that means that this diorite is pretty accurate, which is nice. Now this is andesite, which is exactly the same, or very similar to diorite, except that it's fine-grained. So you can see that the individual crystals, so not the pixels, the little crystals here and here, are smaller than the ones in the diorite and the granite, and that's why it's andesite. Again, very good texture. Now, Deepslate is not the name of a rock. Now, Deepslate does have the name slate in it, which is a type of rock. However, it doesn't look like slate, so we'll have to classify it in a different way. And considering these are all a type of igneous rock, which means that they were cooled directly from lava, we might say that this was igneous. However, this is really dark, like the blackstone and the basalt, and that means that it's mafic. That means it's got lots of metal in it, and this seems pretty accurate considering it's a lot harder than the silicic ones, which are these four. So that's why I'm inclined to believe it's mafic. However, the crystals are nice and big, so that would lead me to believe that it's something called peridotite, and that forms very near the bottom of oceanic crust. Now, this actually forms in the bottom of all the world, but still, that seems kind of accurate, so that's quite nice. Now, this block, tuff, is a bit of a weird block because it's called igneous, but actually that's not how it forms. It forms from blocks of material, so these lighter blocks, like andesite or diorite or rhyolite, coming together and then being cemented together with ash from volcanoes. That's what creates this very odd coloured texture with like the dark and then the light as well. And that's what tuff is. Now this would form in patches, so underground when you get little patches of tuff, again, that's pretty accurate. Now, we move on to the ones that are different. This is blackstone, and, well, it's black, and that means that it's a mafic rock again, and you can see big crystals in it again, which would lead me to believe that it's quite similar to the Deepslate in formation. However, it's much darker, so you could say that there was no silica in this, which is what makes these ones silicic, and it was entirely metallic minerals, like irons and magnesiums, aluminium, that sort of thing, in there. However, these two are different. So that I would say that blackstone is the first of these ones that isn't really very accurate. Now the next one here is basalt, and I really like the basalt in Minecraft. This is because it shows something called columnar jointing, which is where these cylinders that are shown here come together and create like columns. And then if we go into a basalt delta, if you remember, they're like lots of tubes, and that columnar jointing is actually very common, and it forms when the rock cools and then splits apart into like hexagons or pentagons. It's very interesting. So I really like the basalt texture. Now, the next one that we're going to talk about are these two sedimentary rocks. Now, the difference between sedimentary rocks and these mafic rocks, not mafic, that's the wrong word, igneous rocks, is that these form when these ones get ground down into little particles and then compressed together. These we would call sandstone, which they are in Minecraft, and that's because they are lightly coloured, but you can see they've got really big crystals in them, nice big coarse crystals, and that would make it a sandstone as opposed to a clay or some other thing. Now if we actually look at clay, if I find it in the creative inventory, here we go, clay, we can see that the grains are really, really small. And that is actually, again, accurate for clay, which is very, very cool. Now, the last one here is dripstone. Now, I've put the dripstone over here by the sedimentary rocks because it's very porous. That means that water can go through this and drip off from there, as we can see over here by this formation, that the water is like dripping through and creating these stalactites. Now, the problem with this is that it doesn't really look like any other type of sedimentary rock, which is unfortunate, but I do really love the texture, so I think that Minecraft have done well in creating a different block texture that's kind of new and interesting. And again, the dripstone, it's porous, but not. In its texture, you can't really see that there are holes or anything in it, so that's kind of interesting. But anyway, now we move on to the ones that are slightly different. This is calcite. Calcite is actually not a rock, it's a mineral, and that means that it's something that makes up rocks. So that you would say that this diorite has a lot of calcite in it because it's got lots of white in it. However, these are blocks of calcite. Now, on the calcite texture, there are actually these square-looking things, and these, you would say that these are rhombohedral, and that's accurate for calcite. Again, these rhombus shapes, or diagonal rectangular shapes, are very accurate, which again I like, but the fact that it forms in blocks like this is not particularly accurate. Now, obsidian. Obsidian is one of the most difficult blocks to break in Minecraft. And this is actually extremely inaccurate. Obsidian, if you were to hit it with a diamond pickaxe, if you were to hit it with a diamond pickaxe, it would do what it does in creative mode. It would shatter, because obsidian forms when lava cools really, really, really quickly, and then forms like this kind of blob that doesn't have any crystals in it. And that means that it shatters easily, and creates tiny little shards of what we would call volcanic glass. So if you do find obsidian, don't hit it with a pickaxe. It's a very bad idea. Now we're going to move on to, hang on, we'll do netherrack. Netherrack has exactly the same texture as cobblestone, just recoloured, and it doesn't really look like anything, I'm going to be honest. There's nothing that's this bright red. I like that it's got big crystals in it because it forms in the nether where it's nice and hot. Because big crystals form when things cool really slowly, and a crystal like this that's like almost a quarter of a meter would form over millions of years, cooling really slowly, and stuff would cool really slowly in the nether since it's very, very, very hot. So that I like about the netherrack. The next thing we're going to talk about is the amethyst. Amethyst is a type of quartz, and with different colorings in it, and it does form these nice columns like this that are like, you would say that they were crystals, hexagonal crystals that are terminated by a slightly different shape. And that's what this shows, which I like. And then, again, amethyst, it wouldn't form in big blocks like this, but the geodes I do really like, because geodes form when something like calcite forms inside a porous material, like basalt, because basalt can sometimes form with gas trapped in it, so to create little gaps. So the basalt will be filled by the calcite, and then inside the calcite you might have quartz being put down, and that would create the amethyst, which I think is really, really cool that they've done it like that. Now, we've kind of moved on to formations, and the next formation I want to look at is granite. Granite has huge crystals because it forms really slowly. And it forms really slowly due to something called pressure. And that's generally caused by mountains. Now, this granite is incidentally under a mountain range over here, which is pretty nice that there are big blobs of granite, because that is what happens in real life, where the rock will the rock will heat up due to pressure and then melt. Then as it recrystallizes, it will take a really long time and then form this nice granite. However, and a similar thing happens for diorite. If you have a slightly different rock type instead of granite, you'll get diorite. Unfortunately, granite forms everywhere, which is not accurate. Unfortunately, in an area like this, in an ocean, you would never get granite. For two reasons. First of all, there's not enough pressure, because you need mountainous pressure. But you also need granites, as I said, was silicic, which means there needs to be lots of silica. Under the ocean, like this, the lava comes straight from the core of the earth. So underneath the bedrock, the lava would come up, and that means it's got lots of minerals in it, like iron and nickel, and not very much quartz or calcite, which has lots of silica in it, which means granite can't form. So even if it had time to form, it would form peridotite, which is what I said the deep slate was. Now, I think for the geology of Minecraft, we might be done. Honestly, there aren't a whole lot of geological blocks in Minecraft, but I do like the formations of Minecraft, though. Just like the general hills and cliffs. It's very nice. The final thing to mention is this. Surprisingly, this doesn't happen in real life. But that's everything for now. So thank you guys for watching. If you enjoyed this little different video, make sure to like, subscribe, and hit the bell to be notified of my next video. Adios.